Alright, today's lesson. Who can tell me what this is? Okay, nope, it's not a C-clamp. It is, if you ever heard of one, have you ever heard of a micrometer? Some people call it micrometer because that's how it's spelled out. But micrometer, correct term for it. So, for today, especially our engine stuff here, I'm going to show you how to read this. Has anybody ever, well, you probably haven't read one if you don't know about them. So, what if I told you, how many people like math? A few? Alright. What if I told you you only have to count up to 24 or add 24 to an individual number in order to be able to read one of these? So, a lot of people overcomplicate the reading of these, especially it being an analog form. They do make these in digital form as well. Problem with the digital form that I see, it's good for production and things like that. But if I'm only using this a couple times a month or something like that, if I'm machining something or checking something, or I'm working on something and I want to verify the sizes of it, battery's probably going to be dead most of the time that I go and grab it out. So, I like these analog ones. I keep calling them analog. Basically, it's just readings on it. Doesn't need batteries, doesn't require any sort of power source, anything like that. And you pull it out of the drawer, keep it in good shape, and you don't have to worry about anything with it, as long as you make sure it's in calibration and all that stuff. So, but I'm going to walk you through how to read these here. Number one, so most cases down in the bottom, in this lower section down here, I drew this image for you so you can kind of see it blowing up. We have range of measurement. So this measurement is going to be between here. So basically what you're doing is you're putting your part in between here, whether it's round, square, or whatever, and we're going to basically touch the sides of that, if you can imagine just touching the sides of it. What you're not wanting to do is clamp down with something like that. So you're basically just touching, making contact, making sure there's no free play and stuff in there, and you're going to use that to measure. So, this range of measurement here. This is always going to be a number here. I should have put a square here on this one too, but this is always this could vary on numbers. But for instance, if I had this one, if it's 0, it's always going to be in 1 inch increments. So it's only going to measure up to 1 inch, but the starting point actually changes too. So for instance, this one would read 0 to 1 inch. Maximum I can read from this is going to be either 0, and this is going to be in decimals. They do make metric ones of these too, but for what we're doing, we're going to stick with the standard imperial side and do decimals. So this can be 0 all the way up to 1 inch. So any measurement that I get with this is going to start with a decimal point all the way up to 1 inch. Then it'll just be 1 point. So for instance, this one have that, but the maximum you're going to read in here is 1 inch increments. So if this one were a 1 to 2, I could be 1 to 2 inches. That means my minimum is going to be 1, maximum that it can measure is going to be 2. And these keep going up. This could be 2 to 3, 3 to 4, all that stuff. But the one thing you always see is there's always 1 inch increments in there. Okay? So if we have that, we're going to keep this at a 1. So this one's going to be a 0 to 1. This is what we're going to use for our first test. This one here, usually these are indicated on the micrometer. Some of them don't, but a lot of the good name brand ones have them on it. And this might say 1,000, so 0.001. That's going to be the smallest increment that this moves in that you can actually measure with. All right, so that's the smallest it goes down to. So these are pretty common ones. That's accuracy, but a lot of times you'll see ones. If I was going to buy one today, I would make sure I got one that went to 10,000ths of an inch. So all the way down. So this one is a 10,000ths one, and I'll show you how to read that. We're going to break it down in the 1,000ths first, and then we'll go down to the 10,000ths. Okay, so then this is 0 to 1. 1 inch on there, or 1,000ths. So this is going to be my increments up here. So here's where these numbers come into play. So there is 4 dashes equal this total distance. So if I put a 1, a 2, a 3, and the next one will be 4, all the way up to 9 on there, and then the 1 inch. Okay, so these are going to represent hundred thousandths. So if I do a point on here, this is going to be 0.1, or I could write it out as 100 thousandths. So 100 thousandths, 200 thousandths, 300 thousandths, and so on. So there's 4 increments in between there. What would that equal? 25. Okay, so if I got 25 thousandths for each line in there, that means my first line is going to be 025, 050, and 075. Okay, they should technically be backwards, but there's going to be your increments. First line is going to be 25 thousandths, 50 thousandths, 75 thousandths, and then when I hit that 1, that's going to be 100 thousandths. Okay, so anywhere in between these lines, so if I got these 4 lines drawn out, that's those measurements, but what happens if I'm in between 25 and 50? That's where you're going to read this barrel. So this part turns over top of this sleeve, and what you're reading is you're reading the exposed dashes and exposed numbers on here only, and then you're reading this corresponding line here. So let's give an example of this. Let's put this at a 0, this being 24. Whenever this is at 0, it has to line up exactly with the line over here. So if I'm at 3, my next line, you're going to see a 4 semi-exposed on that side, and this line being on 0, that lines up with this 0 line on there, that's going to represent an exact 0 mark. So if I'm at 4, if I see a 4 exposed, I got my 3 lines exposed after the 3, and I got it on 0 on that center line, my reading is going to be, 400 thousandths. Okay? For every line that this goes up, it's literally just adding 1 up to 24 lines onto one of these increments. Okay? So that's where it really simplifies it. If I get rid of this here, get rid of that 4, and let's pretend we got 3 lines exposed past the 3. So we're going to read this in order. I know that I'm under an inch, so I'm going to put a point there, my decimal point. I have a full number exposed of 3, so I'm going to put my 3 on there. The next line I'm going to do is I'm going to count how many lines I have exposed on this side. And let's give this a number of 15. We'll do 14, 13, 12, and then this will be 16, 17, and so on, okay? When it's a longer line like this, these are usually in 5 increment, and then the longer line will be at the 5 points, so 5, 10, 15, 20. And so what you do then is you have 3 lines exposed, so that means I have my third line, 75 thousandths, okay? But I look over here, I'm not at the 0, so I'm not quite to my 400 thousandths. I read this number at 15. Here's where the only math comes in that you have to do. You have to add 15 to that 3 lines exposed to that 75. And what do I got for that? 90 thousandths. So what I'm going to do is put that next to it. This would technically be 0 if I want a 90 thousandths, but I'm going to go over in this position here, and I write 0.390. 390 thousandths would be my reading on that, okay? Any measurement that I get in there, you're just adding these numbers only up to 24 on that. So if this line ended up at 24, then I would be, let's just pretend this 24 was at that number, max I'm going to be, my 24 under my 75 is 99. That's the max number I can even add to that, would be 24 before it hits the 0 mark again, which represents 25, or dead one of those 3 numbers, which would be my 400 thousandths. Does that make sense? Okay, so now, and we'll practice this a little bit once we get started here. Now what I want you to do, so that's 1/1000ths, that's the reading for that, okay? Now let's say I turn this over and I want to make this, get rid of this line here. Let's pretend this mic goes to 4 decimal places afterwards. So this is where, this is a top view of this micrometer. So if I turn this micrometer up to the top like that, you will see lines indicating on the top. And I know you probably can't see these numbers up here, but I'll explain what they are up here. So there's lines, and they're marked 1 through 9 up there, and then there's a 0 after this one up here. So I got 1 through 9 and a 0. What this is going to do is, let's pretend that this ended up in between that 23 and 24. What you're going to do then, so I got my number of 399, what you're going to do then is, say you're like looking at this isn't exactly in 24, it's above 23 but not quite to 24. I'm going to flip the mic over, it's on my reading, and I'm going to look, and all these lines are indicated with these lines that are over here, the thousandths lines, are going to end up with the 10,000ths lines. And what you do is, all you do is look for the line that is the closest lining up, the true line with each other. And there might be like 2 that are real close, but 1 will be dead on. And what you'll do is you'll find out which of these numbers is dead on to that number. And let's say 6. Let's say, it doesn't matter which one of these lines is lined up. You don't read this actual number on the barrel here, which would be these thousandths numbers. What you do is you find out, let's say this 9 lines up exactly with 6 on this number here. What you do is you literally take that 6 and add it to your 4th place in there. See how easy it is? All you are to read a micrometer is literally reading it. You're just looking at it, what numbers are exposed, what numbers line up down here. Okay? That's all we're doing with this side. The thing you're going to get is the feel, and holding these things kind of awkward, especially for the first time, but you're going to basically turn this down until you touch it, and this has a ratchet stop up here. Some people like to use those. Once you get the feel of them, you really don't need to, but what that is it almost has, now this one doesn't have one of those on it, it just has a smaller turn on it. But a lot of times with this is a ratchet stop. I like to call them a clutch too. They basically don't let it get too tight and it starts kind of clicking like a ratchet. Okay, but it only goes the one direction, then you can back it off. You can see parts of this in when you look it up for your lesson chapter work there. You're going to see, and you're going to have to name all these components and stuff. I'm not going over that. I'm basically just covering this as part of your learning, if you can't. And you can always reference this too online as far as identifying components and stuff. But that's not what I want this part to be. I want this part to be physically reading it and understanding how to read it, because they're super simple once you get this down. So now what we're going to do, since we got that all practiced out, or we're going to practice this out, it doesn't matter what number that lines up with. Remember, this could be an 8, whatever. So we got that side done. So okay, so now I'm going to switch to my second slide here. So this is our practice. See, that's the top view of it. Oh, front view and top view. Okay. So this is what you're going to reference here. So when you're doing these practice things on here, and it's kind of hard to read. It's even harder to read on here. I'll have to look at the computer on there I can read the actual numbers, kind of blurry. So what you're going to do here is this is the front view, this is the top view of it, okay? So this way we can practice both numbers doing to the 3 decimal places, 4 decimal places, we'll add it in there. So our first one, if you can see that, we got a number exposed on there. I'm going to write this next to it here. Okay, so I know I'm going to put a decimal point here because I'm not up to an inch. And these, it says up here, assume that this is a 0 to 1 micrometer. So anywhere from 0 all the way up to 1 inch. We know we're less than 1 inch because we don't have the 1 exposed or the 9 exposed up at the top. So we got 4 is listed on there. So I'm going to write 0.4 will be my first number. Okay, and I have one line I see exposed here, and remember, one line exposed, yep, 25 thousandths. So what I'm going to do here is I'm going to write 25 below here. Okay, this will be for a reference down here. These will be my actual numbers. I'm just going to do this so you can visualize it. So I look over here. I'm not exactly at 0, so I know I'm not 25, and I'm not at a 0 point because I see the 25 there, so I'm not at 50 yet. So what I'm going to do here is I know I got 25 for sure because I got one line exposed, so I need to read my numbers on the sleeve. And I can't quite see the numbers on the thing there, but it looks like we have, looks like 6. So we got, this is a 5, this is 6, there's 7. So I'll write this 6, 7, it's a 5 on there. If I look here, it says 6, so I literally write down 6 thousandths above the 25. So I got 31. So I'm going to go, I add those two together, I can put that right in there. My 25 plus my 6 thousandths, I got 431 thousandths. Now the reason I put 6, even though you see it's closer to the 7 than it is the 6, is it's not exactly on 7. So that's when, so this would be my number for 3 places past. Well, now I flip over to the top because I'm not exactly lined up. And I look here, and I believe this is a 15. It looks like I got 15. And look here, my 16, which remember, these numbers don't matter except for visualizing to line up the lines. My 16 is exactly lined up with 5. Okay? So 16 line up with 5. That's a 5 there. 16, remember this number doesn't matter. That number is the one that matters. Literally, all I do is write the 5 there. That's my measurement to 4 places past the decimal, reading the face of this and the top of this. Okay? Let's go down and do this one here. First number I got. Yep, 2. So I know I'm down below. I got a 2 there. Do I have any lines exposed on there? No, I don't. But there's a gap there, okay? So I know it's less than 25 thousandths. So now I'm going to read this barrel here. And I have 15, 16, 17, 18. And it's not quite to 19, okay? I'm in between 18 and 19. So I can write down, I know I got 18 there. I don't have to add it to 25 because that's the number. So I can literally write this right there. 18 down, not quite to my 19. So now I'm going to flip over here, and the closest line I got lined up is right here, which looks like a 3, I think. Yes, it's a 3, okay? Okay, that line's lined up with 3. I literally just transfer that number over to that. That's the number I have for this reading here. Okay? Let's go down and do this one. This one is below, so I'm still starting with the decimal point, but I don't have a whole number exposed. So what do I do for that? I would have a 0 there, correct? Okay, so now I have how many lines exposed? Yes, I got 3 lines exposed. So 75 thousandths. So I know I got 75, but I'm not up to there yet. So I'm just going to write this number down here. We don't lose track of it. 75, this is 10 right here, okay? 11, not quite to 12. So I'm going to add 11 to that, and I got 86. So 86 thousandths, total number reading on that. And then it's not quite to the next number there, so we're going to line it up with our top view, and that line lines up directly with 8. So we got, 8 lines up exactly on there. There's our measurement. Okay? Very simple to read these. You don't need to overcomplicate it. You'll probably actually, after looking at this, you'll have more trouble holding it and measuring something with it. So what I want you to do is I want you to take and get your, open up your sheets and stuff on this. Practice all of them that are listed there. If you're doing this at home, you can also get this off of, you can look up some Google sample ones and stuff and go ahead and practice. Just practice reading it. Then separately, you should practice actually using it. So, a couple things I want to go over. If you're going to purchase these, which I would if you were, here's the deal. You can get these relatively cheap. What I would do is I would stick to a name brand one, a good made one. You can get them cheaper made ones and stuff. But what I end up doing is I end up going to somewhere like eBay or something like that, and I find new ones that somebody's selling. Either a business, a company went out of business, a factory or something like that, and they're selling them off. You have machinists and stuff that retire and things like that. They'll sell good used ones of these every day and be a fraction of the cost of the other ones. And you can get these recalibrated and stuff like that too, but a lot of times that's what I end up doing. All the ones I got at home, they're all used, they're all name brand ones, and they're all really good and accurate. So that's what I would do. I'd steer clear of the really cheap ones if you want to. Depends on what you're doing too. You can get one. You can get them really cheap, probably even $10 or something like that for a cheap made one. But you're going to have way better accuracy and stuff with it on. You want to protect these things. They usually come in a case. You don't want to drop them. We're talking really, really fine measurements here and stuff. And you want to keep them in good condition. Another thing is they usually come with a block. That's a 1-inch block. It's a predetermined, it's usually made out of metal and stuff in there. And what you'll do is you'll put that in there and then crank this back down and get down to your 1-inch. Touch that on there. This should measure exactly 1 inch and have the 0 line lined up and everything. And they do come with a little wrench that hooks in the back here, and that's going to rotate, and you can actually self-calibrate them at home with one of those blocks. So that's what I would recommend doing if you're going to do it. Practice with one of them. They're super easy to read. They're handy. You can use them for tons of stuff. Just replacing engine parts and stuff. If you do any kind of machining, just checking parts, whatever. They're real handy to use. So this one's a 1 to 2 mic. We'll be using the 1 to 2 mics today, and the 0 to 1. So what I'm gonna have you do is go ahead and do your practice ones first, and then what I'm gonna have you do is get your camshaft. When you go back to lab, get your camshaft and your crankshaft to your engine out. And I have the sheets and stuff all back there for you, but you're gonna go ahead and measure in 4 places, actually 6 places on the cams. They're on there. I want you to measure each journal on the end there, and then you're going to go ahead and do your intake and exhaust lobes. And I want you to measure the top and bottom of the egg portion, and then your baseline. I want you to measure the base of it. Record those numbers on all 6 of those. I want both bearing journals, both bases, and both lifts on the lobes there. So you're going to do that, and then on your crankshaft, you're going to pull that out. You're going to do your connecting rod journal. Measure that. That's the one you'll need the 1 to 2 mic for. The rest of them you should be able to get away with your 0 to 1 mic. Okay? And then you're going to measure the journal on here on the PTO side, and then on your flywheel side you'll measure that journal as well. So 3 spots on the crankshaft, technically 6 on the camshaft. Any questions at all? Okay, I'll come back. You guys go ahead and start doing your practice sheets in here. I'll walk around, help you out. We're going to go ahead and pass these around so you can see them, get a feel for them in your hand. And then I'll be walking around into the lab side, and we'll go ahead and walk you through all that. I'll have you get comfortable with it. And remember, you're just not cranking down on these. It's a fine touch. You're basically just touching it with no air gap and no play or anything in it. You're just touching it on the ends to get your reading. And then you'll go from there. So, all right. Let's go ahead and get to it here.